Hey guys, welcome to Fun Learning. In this video, we are going to discuss about the vertebral column biomechanics. With no further delay, let's get started. Vertebral column consists of 33 vertebrae and 23 intervertebral discs. Okay. Now let us discuss about the curves that is present in the vertebral column. We have two types of curve, which are nothing but kyphotic curve and lordotic curve. Kyphotic curve are the curve with posterior convexity, whereas lordotic curve are the curve with anterior convexity. Okay, so kyphotic curve is a curve with posterior convexity, whereas lordotic curve is a curve with anterior convexity. And the kyphotic curve is referred to as the primary curve, whereas lordotic curve is referred to as the secondary curve. Why? So when the fetus is in the womb of the mother, there is only one curve present in the vertebral column, which is nothing but the kyphotic curve. Okay, that is the curve with posterior convexity. So once the baby is born and their head stand erect, அப்போ cervicalல lordotic curve develop ஆகும். Okay, அதுக்கப்புறம் when the baby started walking, lordotic, that is lumbarல lordotic curve develop ஆகும். Okay, so lordotic curve is referred to as the secondary curve. Okay, so there are two curves, so two kyphotic curve and two lordotic curve. Two lordotic curve is present in the cervical and lumbar region. Now let us discuss about the mobile segment. So mobile segment is nothing but the two adjacent vertebrae, intervertebral disc in between, and all the soft tissue that secure them together is referred to as the mobile segment. Okay, so two adjacent vertebrae, intervertebral disc in between them, and all the soft tissue, muscle, ligament, all those things that secure the two vertebrae together are referred to as the mobile segment. Now let us discuss about the typical vertebrae. So the structure of the typical vertebrae. I hope so you learn about the structure of the vertebrae in anatomy. So now let us discuss about here briefly. So the vertebrae consist of two important parts, which first part is the vertebral body and second part is the neural arch. This neural arch is interdivided into pedicel and posterior element. In this posterior element consists of four important structures, which are nothing but laminae, transverse process, spinous process, and articular process. And there are four articular process, which is nothing but two superior articular process and two inferior articular process. So these are the structure that is present in a typical vertebrae. Okay, so any force from the posterior element, that is either from the laminae or from the transverse process or from the spinous process or from the articular process, is transferred to the vertebral body via the pedicle. Okay, the force transfer, for example, if the force has to be transferred from spinous process to the transverse process and to the laminae, from the laminae it will go to the pedicel, from pedicel it will transfer to the vertebral body. So there is a specific region in the laminae that take part in this force transfer, and that region is referred to as pars interarticularis. As the name suggests, this structure is present between the two articular processes. Okay. Now let us discuss about the intervertebral disc. Intervertebral disc has two principal functions. As we all know, the intervertebral disc are the disc which is present between the two vertebrae. It increases the space between two vertebrae, thus thereby increasing the range of motion. So another important function is intervertebral disc helps in transmitting load from one vertebrae to the other vertebrae. Okay, well, so as we know, the magnitude of weight transfer increases when we move from cervical to lumbar. Thus, the size of the vertebral disc also increases when we move from cervical to lumbar. Okay, and there is a ratio that determines the amount of motion that is available at that uh, particular region, for example cervical, thoracic or lumbar. So that ratio is nothing but a ratio between disc thickness and vertebral body height. So this determines the available motion, and this ratio is greater in cervical, lumbar and thoracic. Thus the range of motion is more greater in the cervical, followed by lumbar, followed by thoracic. So the vertebral column, that thoracic has the least mobility. Okay, and this intervertebral disc has three parts mainly, which are nothing but the nucleus pulposus and annulus fibrosus and the vertebral end plate. Okay, now let us discuss about the nucleus pulposus, annulus fibrosus and vertebral end plate in detail. First, let us discuss about the nucleus pulposus. So, nucleus pulposus has a greater amount of water. That is, 80% of nucleus pulposus is being formed by water. Okay, the remaining 20% are nothing but the dry weight. So, among that dry weight, the majority of dry weight is being formed by glycosaminoglycans, because this glycosaminoglycans has a property of attracting the water molecules towards it. Thus, nucleus pulposus the dry weight of nucleus pulposus is majorly being formed by the glycosaminoglycans, and it also consists of collagen. So there are many types of collagens, right? So among that, type 2 collagen is predominantly present in the nucleus pulposus. Okay, because type 2 collagen are the collagen which can able to resist compressive force. Okay, so and the remaining dry weight are nothing but the chondrocytes, elastin, protein and proteolytic enzymes. Now let us discuss about the annulus fibrosus. So annulus fibrosus 60% are water, and the remaining 40% is nothing but the dry weight. So among the dry weight, the majority of dry weight which is present in the annulus fibrosus is nothing but the collagen. And here type 1 collagen are predominantly present in the case of annulus fibrosus. Okay, so nucleus pulposus we have 80% of water and 20% dry weight. Among that dry weight, we have glycosaminoglycans is a majority of dry weight. Okay, that is present in the nucleus pulposus. Whereas the 60% water and 40% dry weight. Among that 40% dry weight, collagen is a majority of dry weight that is present in the annulus fibrosus. Now let us discuss about the vertebral end plate. So vertebral end plate are nothing but this structure. So I hope so you can see this diagram. So this is nucleus pulposus, and the lateral vala is nothing but the annulus fibrosus, and this dark green color denote the vertebral end plate. This vertebral end plate also have water, collagen, chondrocytes, elastin, all those things are present in the vertebral end plate. In addition to that, vertebral end plate consists of cartilage, which are nothing but the fibrocartilage and iron cartilage. Both the cartilage are present in the vertebral end plate. Okay, among that, the hyaline cartilage are present closer to the vertebral body, whereas the fibrocartilage are present closer to the nucleus pulposus. Okay, so initially two types of cartilage are present in the vertebral end plate. But later on, when we started getting older, so age aga, the hyaline cartilage will be replaced by our fibrocartilage. Okay, I hope so you understand about the intervertebral disc. And the very important thing you have to remember here is the nerve supply of intervertebral disc is nothing but vertebral nerve and sinovertebral nerve. And the outer portion of your intervertebral disc is being supplied by the metaphyseal artery. Okay. So the remaining portion of your intervertebral disc depends on diffusion for nutrition purposes. And now let us discuss about the articulation. So there are two types of joints that are present in the vertebral column. The first one is the intervertebral joint and the second one is zygapophyseal joint. Interbody joint are the joint which is present between the two vertebrae and intervertebral disc that is present between them. So that is the interbody joint which is nothing but the cartilaginous joint. And zygapophyseal joint are nothing but the facet joint and that comes under the synovial joint variety.